Hello everyone, my name is Matthew Wilson, and this is our second sequential circuit. So to help us analyze this sequential circuit, we're going to look at two things here, our state diagram as well as our state table. So basically to go ahead and test this circuit, what we're going to be looking for today are the outputs of 1. And if we go ahead and look at our state table here, we can see outputs of 1 when D is 1, so a state named D, which if you look here, D is 1, 1 with a output or input of 0, which will give us back to our A. We also have 1, 0, 1. So if we put our input of 1 and do 1, 0, it'll give us an output of 1. If we do 0, 1 with an input of 1, 0, 1, we will also get an output of 1. And 1, 1 with an input of 1 will also give us an output of 1. And basically a common catch here, a common pattern you guys may recognize is that every single time the input is 1, it'll always go back to our A state, which really helps us in understanding the sequential circuit. Every time our input is 1, it'll go back to this A. So even if the inputs are, even if these Q0 and Q1s are 0, 0 here, and our input is 1, it'll still go back into itself and still leave it at A. So in order to define the process of the sequential circuit analysis, we're going to first start with our equations, which these are actually just equations based off of the circuit that I've already shown you guys previously within Logism. So we get our terms J0, J1, K0, and K1, and our equation for Z as well, which can just be shown here with our Logism circuit. K1, J1, Z, along with our Q0, Q1. The next step in our process will be our state table. This may look a little confusing at first, but it's actually pretty simple to understand. So we've named the states here A, B, C, and D, and these are all representative of, they each have their own inputs, so they're the same. This is why there's two of them. So there's 0, 0 with an input of 0, 0, 0 with an input of 1, B with a state code of 0, 1 and an input of 0, and then a 0, 1 with an input of 1, and so forth down the list. Our FF inputs were based off of our equation table. Then our next state is going to be, you're going to be looking at these columns here in relation to what they do, which will lead us to our third step in a sequential circuit analysis process, which is our state diagram, which basically gives us a nice little map of what happens with the Q0 and Q1s of 0, 0, and an inputs of 0 or 1. As I mentioned earlier, this is a Mealy machine, or a Mealy circuit, and we can tell that because the outputs are functions of the state memory, which we can see here, and the current inputs as well, which is our X tunnel that we have set up here. And that word I just used there, tunnel, tunnels are basically ways to kind of take your code and put it all over the circuit board however you'd like without having to cross wires. So basically what you can kind of do is like this X goes into our tunnel X, and now I'm able to freely use X without having to fully connect the wires. But the more technical term of this could be that it binds 2 points together And this is mainly helpful when you need to connect points that are far apart in the circuit, like I stated previously. And with having to connect all those wires without the use of tunnels, everything would look a lot uglier and be a lot harder to understand. So these tunnels are a very nice addition. And to use the tunnel, it's pretty simple. All I do here is just, if I wanted to set an input, I grab a tunnel from our wiring tab, connect it to this, and we'll go ahead and name this H. Now if I wanted to, I can go ahead and copy and paste this H tunnel, flip it around, and connect this to an output pin. So if I go ahead and turn this on, it'll give us an output of 1 without having to connect these wires. And I can essentially just move this anywhere I want, anywhere around the board, making it super useful in creating circuits and making them look a lot more clean. And that is all I have for you guys today. Thank you.